Hello, everybody. Welcome to today's lecture. Last time we started Chapter 6, we're pretty much done with Chapter 6. There's just a little bit more to talk about in 6.2. But just as a reminder of 6.1, we talked about the normal distribution, specifically the standard normal distribution, and what a z-score is. Okay, so now we're going to look at, and we also talked about the empirical rule. So the empirical rule tells us if we know the mean and the standard deviation, then we can find, for example, where like 68% of the data is. So in terms of probability, as an example, this would mean that the probability that something is within one standard deviation of the mean from the empirical rule is 68%. Like if we were picking a piece of data at random, there's a 68% chance it falls into that range. So what we want to do in 6.2 is look at, okay, what if it's not perfectly one standard deviation? What if it's, some other number? How do we calculate the probability in that case? Okay. So just as a way of looking at some of the notation that we're going to be using, okay, using the empirical rule, let me copy that picture over, this one. Okay, so we'll use this. If we wanted to say find the probability, so the probability that our number x is below the mean, so x is less than mu, and I'll do some with actual numbers here in a second. Well, we can see this is perfectly symmetrical. So 50% of it is going to be on the left side of the average, and 50% of it's going to be on the right side. So we can just calculate this as 0.5, right? Let's put some numbers in here. Okay, let's say x is normally distributed as with mean 12, standard deviation 3. Okay, I think these are the numbers we used yesterday or something close to that. So using the empirical rule, let's say first of all, the probability that x is less than 3, less than 12, is equal to 0.5. Because the average is exactly the halfway point, right? We mentioned that the mean and the median are the same thing. If this is the median, then that means it's exactly halfway through the data. So the probability that x would be less than the median would be 50%. And on the other hand, the probability that it would be greater than 12 would also be 50%. Okay, so this is just one of the types of questions we're going to want to ask now. Instead of looking for the probability at a specific value, we're going to look for the probability in a range of values. Okay. Actually, for reasons that are a little hard to explain without using calculus, I can try to explain it with the picture. If we have a continuous distribution, like we do here with the normal distribution, the probability that x is equal to a number is always going to be 0. Okay. Like I said, we really would need calculus to show this mathematically, but we can try to understand this using the picture. So say this is 12, in our case it is. Remember, the probability we're looking for is the area underneath this. The area at one specific number, well, its height is going to be something, but the width of a single point is really 0, right? That's actually the definition of what a point is in mathematics, is something with width 0. So it's very technical, but you can imagine if if we're looking at like a slice of this and finding the area, that's fine. But if we just have one single point, okay, let me draw it over here. Say we have this, right? And this is 12. If we're trying to find the area of this line, well, the height is, whatever it ends up being, but the width is going to be 0, because the width would be like, say if we had 10 right here, right? Now this width is 2 because we do 12 minus 10. But if it's just that one number, it's like we're doing 12 minus 12, so the distance is 0. So we would have 0 times whatever the height is, which would give us 0. So the probability, when we're dealing with continuous distributions, we're not really looking for the probabilities at a specific number anymore, because that would always be 0. We're looking at the probabilities in a range of values. So what's the probability that x is less than 12? We could also throw a less than or equal to here, because it wouldn't change anything, because it can't be 12 anyway, right? The probability that's 12 is 0. So we're always going to be using less than or greater than signs, essentially, is what I'm trying to say here. What is the probability that x is between 9 and 15? So this is another type of question we might want to ask. What's the probability that x is greater than 9? You can have equal to, or it doesn't really matter, like I said, or less than 15. Well, notice this is within one standard deviation of the mean, right? 15 is equal to 12 plus 3. 9 is equal to 12 minus 3. So from the empirical rule, this should be 68%, or 0.68. Okay. So it's the same thing we were looking at last time. I'm just writing it in terms of probabilities this time. We went 2 standard deviations away, so to 6 and 18, right? This is 2 standard deviations would be 6, since our standard deviation is 3. So this is, the right number is 12 plus 6, the left number is 12 minus 6. So by the empirical rule, that's it's going to have a 95% chance, so 0.95. Okay. Let's do a little bit of a trickier one now. What is the probability that x is less than or equal to 15? Or we could just do less than. Like I said, it doesn't make a difference. Okay. 2 ways we can solve this. First of all, so 15, that's going to be at this part for us, right? Because it's 1 standard deviation to the right of 12. So we're looking for the area of all of this part up to this line. So let's redraw the picture here. Okay, so here is 12. Here is 15. So we're looking for this area. Now we can't just find the area underneath the curve, because we don't have calculus. We can't find the area underneath curves, but we can use the empirical rule. The empirical rules that we have with the 68 and the 95 and the 97, and put that all together. Okay. First of all, we know that this region is 68%. Okay. So we know it's going to be more than 68%. So we're essentially looking for, okay, what about these 3 regions here? Okay. Here, let me get rid of this and just paste that picture again. Okay. We don't need all of this. And here, I'll replace these with some actual numbers. So our mean is 12. Whoops. Whoops. All right. Our mean, sorry, it's not showing up right now. That's fine. So our mean is 12. One standard deviation away is 15. And 9 on the other side. This one's 18. This one's 6. That's 2 standard deviations away. This one's 21. This one's 3. Okay. So now we want to find this area. Okay. Here, let me use a different color maybe. Okay, we're trying to find this area. And we already can see part of it. We know from here to here is 68%, right? So just putting together what we know it's 0.68, but there's more because these two regions that we had were 68%. Now we need this region, and this region, which is going to be a little bit trickier. Let's start at this region. Okay. So notice from here to here is 95%, and from here to here is 68%. So if we took off the 95 we took the 95 and subtracted off the 68, we're gonna get 27. Okay. So that means that this region right here plus this region right here has to have a total of 27%, right? Because that's these two added together being 27% plus this one being 68% gives us the total of 95%. And again, they're symmetrical, so they'll each have half of that. So 27 divided by 2 is 13.5. Okay, so this is 13.5%. So this will be 0.135. And then we just need these two regions. And then we can do the same thing. Okay. This whole thing is 99.7%. So if we want to find these regions, we just subtract off the 95%. Okay, that'll give us 2.7. And then again, it's symmetrical, so each of them have exactly half of that. So 2.7 divided by 2 gives us 1.35. So this is 0.0135. And then finally, we just need this last one. Well, from here to here is 0.3. From here to here is 99.7%. Overall, this has to add up to 100%. So what's left over is 100 minus 99.7, which is 0.3. And then each little part of this has half of that. So 0.3 divided by 2 will be 0.15%. So 0.0015 is how we'd write that as a decimal. So now we can add all these together. Okay. to ultimately get 83%. So the probability that it's less than 15 is 83%. Okay. All right, now one thing we're going to want to be comfortable with also is finding the opposite probabilities, the complement probabilities, because oftentimes it's easier to find the complement. So a second way I could have done this problem, which really would have been just as much work, is I could have said, okay, the probability that x is bigger than or less than 15. Yeah. The probability that x is less than 15 is equal to 1 minus the probability that x is bigger than 15. Technically greater than or equal to 15, but again, the equal to part isn't making a difference here. So then I could have found, okay, what is this region? And then I would have had to find this part, and this part, which we already did. It's just pretty much everything except for the 0.68. So it would have been just as much work. But ultimately, we would have had one less number to add together. In some problems, though, it might be easier to do. So if we did that, this would have been 1 minus 0.17, because we would add the last three numbers together and get 0.17. And let me just make sure that's all right. 0.17, yeah. Yeah. And then we would come up with the 0.83. Okay. So we're going to want to be able to flip back and forth between the regular probability and its complement probability. Okay. So this works fine if we know the mean and we know the standard deviation and we know like we're looking for something that's on one of these lines, right? But what if we wanted to know what the probability is that x is less than 14? Okay. What's the probability x is less than 14? Okay. Now this empirical rule isn't really going to help us because we don't know exactly how, like 14 is like right here. We don't know exactly how much of that 68% is getting cut off. Okay, so now we would need a calculator or Excel. But the next question is, how do we even do this in Excel? Okay, so let me show you guys. Let's get Excel up here. And I apologize. I realized in some of my last videos my face was covering the Excel tab. So I'll make sure to keep it on this side now. So we're going to go to more function statistical just like we always do. And we're going to look for normal distribution, okay? So there's a few different ones here. There's normal distribution. Okay, this returns the normal distribution. The normal S distribution is the standard normal distribution. So if we're using a standard normal distribution or if we standardize our stuff, this is what we're going to be looking for. But we're just going to go with this regular normal distribution for now. So you should get this box. So X is the value that we want for the distribution. So for us, that's going to be 14, right? So this is like our data value, the 14. It's not talking about this X. This is our random variable. It's talking about the specific data value. What's the mean? Well, our mean is 12. Okay. What's our standard deviation? 3. Do we want it to be cumulative or not? Okay. So what does this mean? Well, This means the cumulative distribution function we didn't really talk too much about, but this means it's like the cumulative column that we had on our frequency tables, if you remember that. We didn't do a lot of problems with that, so it's okay if you don't. But essentially asks something like this. What is the probability that x is less than 14? Okay. So if this is the kind of question that we're asking, then we're going to say true. If we have what's the probability that x is less than something, we're using the cumulative distribution function. Okay. You can say it's going to say 0.74. If we say false, it doesn't use the cumulative distribution function. It uses the probability density function. Okay. We're using true here, so it's going to be 0.74. Okay. Right, 0.74, 75. So this makes sense because it's a little bit less than 0.83 because we have a little bit less area here. Okay. Okay, so let's there is a way to do this without using Excel. And this is probably a much more common way to do it. And that's by using a table of values. So in the book, we have some tables here. They are actually at the end, right here, I think. Tables index, yeah. So you'll notice on this part, there's something called the normal table. And it actually gives you a little nice introduction of the normal table here. It talks about the standard normal distribution and the cumulative distribution function of that. And then it gives us this table, which, I mean, probably looks like nonsense, right? But it's, this is definitely the most common way to find values for the normal distribution. Now, notice, like, there's really no way to do this unless we standardize everything, right? We need to have the standard mean and standard deviation. Otherwise, there's no way for us to really do this, okay? And there's different types of the tables. This one gives the area under the normal curve from 0 to your value. So 0 is the mean because we're always going to be using the standard normal distribution. We have to standardize everything first. So this table gives the value from 0 to some value. So for example, if we wanted 1, this number in the leftmost column, this is the value you're looking for to 1 decimal place, and this is the second decimal place on the upper column. So for example, at 1, this number is for 1.00. This number is for 1.01. This number is for 1.02. This number is for 1.08. Okay. So the area under the normal curve from 0 to 1 would be 0.34134. In other words, the probability that x is between 0 and 1 is 0.3134 if x has a standard normal distribution. Okay. Of course, we don't have a standard normal distribution here. So what are we supposed to do? Well, one thing we can do is we can standardize it. Okay. If we think back to the z-scores, where was that? If x has a normal distribution like this, then this is the z-score, right? So what we want to do is we want to take our value and find the z-score. Okay, so let's go back and take our 14, right? And we're going to do minus the mean divided by the standard deviation. Okay, so it's going to be 2/3 or 0.67 if you want to use decimals. We should use decimals. Okay, because we're going to have to use that table, and that table has decimals. So this table will tell us the probability of being between maybe it'll be easier if I show the picture here. Our z-score is about right here at 2/3, right? So the table is going to give us the value between 0 and 2/3, okay? Now, we want the area to the left of the z-score, just like we wanted the area to the left of 14. So we need a little bit more than that. We need also all this part, but luckily this part's always going to be 0.5 because the area to the left of the mean is always 0.5. So whatever we get from the table, we're going to add 0.5 onto it. Okay. So we're looking for 0.66, which is going to be right here. Okay. So 0.24537. So it's a little less precise. Okay. So from the table, this is 0.24, what was it, 537? 537. But then we got to add on that 0.5. So we get 0.74537. So it's the same up to 2 decimal places. This is more precise because here we had to round pretty severely. It actually would probably be better if we did the 0.67 spot, which is 0.24857, because that's what it would really be rounded. Let me do that instead. But they're always going to vary slightly because we're going to have to round. Yeah. So this would be 0.74857, which is almost this, right? Now, if you wanted to find a number, if you didn't want to have to add that 0.5 onto it, if you just wanted to find the z-score and then get it from there, there's other tables other than this one. This gives, the other tables on here are tables we're going to use later. So don't worry too much about those. But we can do CDF normal table. Let's go to the first Wikipedia tab here, the standard normal table. So this is the one we were just looking at. So you can see the 0.67, 0.24857. What we want is this one. Okay. And it has some negative values and some positive values. If we just go straight to the 0.67, here you go, 0.74857. Okay. So this gives you the area just to the left of that number, which is what we're looking for here because we're finding the probability that x is less than that number. So it gives us the 0.74857. So this one's, I mean, it just depends on the context of which one you want to use. Here's a table that gives you the value to the right, which would just be 1 minus the number that we found. I don't know if there's any others we'd want to use. Yeah. This is probably the most helpful one though. I'll put a copy of this table on Canvas. I'll put a copy of a couple of the tables with explanations for when you want to use each one. Okay. I don't care if you use the table or if you use Excel. It's commonly used in tables in schools because that's how it's easier for tests, right? If you don't expect everybody to have a calculator, you can just attach the table, and then like you can attach the table to the test so that everybody can find the values that way. Okay. In practice, like if you were doing this on your own, it would be more likely you'd do it in Excel because you'd want it to be more precise, or maybe some other programming software. Okay. Let's go through at least one more example here. Actually, I spent a lot more time on this than I expected. I didn't realize there was so much information in this chapter. Here, I can just make up another one. So let's say we have here, all right, let's say we have a mean of 56, standard deviation of 15. Okay. So X is normally distributed with 56 mean, 15 standard deviation. And then let's say we want, what is the probability that X is, let's say greater than, I don't know, 100. Okay. So notice it's greater than this time instead of less than. I think it's always helpful with these to start by drawing a picture of the normal distribution so you know what region you're trying to find. Okay. So just a quick sketch. If we have this distribution, the mean is in the middle. So 100 is going to be somewhere over here. And if we're finding the value that X is less or bigger than 100, we're going to be finding this region. Okay. So the region to the right of this. Okay. So most of the tables you'll look at will give you the region to the left of this. Okay. So because of that, it's going to be easier to find the complement probability. 1 minus the probability that X is less than 100. Okay. So 1 minus this region. So the idea is the whole region is 1. So if we subtract this part off, we'll just be left with this. Okay. So let's use the table to find this, but we can't use the 100. We have to standardize it first, right? So our z-score is 100 minus 56 divided by 15. Okay. Which is going to be 3.73. So if we go to the cumulative table, do I still have that? No. Okay, so this is the table that gives us from the middle to the number, so we would have to add 0.5 to it. That's fine though. We can go to 3.73, which is right here, 0.49990. Okay. So it's equal to 0.4990 plus a point. Was there 3 nines or 2? 3. And then we got to add 0.5 to it. So we get 0.99990. And we're doing 1 minus that. Okay. Which is going to be 0.00001, I want to say. Yep. So, in other words, there's almost a 0% chance here. So, to use this table to recap, this gives us the area from the middle to the number. And then we have to add the other side onto it, which is always 0.5. Okay. And that gives us this region, but we want the opposite of that, so we did 1 minus that. Okay. Let's do another one with these same numbers that's not so extreme. Let's say, what's the probability that x is more than 82? Okay. So 82 is going to be somewhere like right here, right? So we're looking for this region. Again, most of the tables will give us the other side. So let's do 1 minus probability that x is less than 82. So from this table, sorry, first of all, we need the z-score, right? Let me do that on the side. We always have to find the z-score first. Minus 56 divided by 15. So 82 minus 56 divided by 15 is 1.73. Okay. So from this table, 1.73 is right here. So we're at 0.45818. Sorry, just to correct this should have been in parentheses, because we want to add these first and then do 1 minus that. So just the order of operations. So we're adding these together and then we're doing 1 minus that. Okay. So 0.5 plus 0.45818 is 0.95818. And then we do 1 minus that to get 0.04182. So 4.182% chance that x is above 82. Okay. So again, there's some other tables you could use. If we go to this Wikipedia table for the cumulative function, we could just find 1.73, which is right here, and then we get that 0.95818, which we had right here right away. Okay. And then if you scroll down on that Wikipedia page, it gives you the complementary cumulative function. And this is the probability that you're to the right of the value, which is exactly what we're looking for. So we wouldn't even have to do the 1 minus. If we use this table, we would get this value right here with our 1.73, which is 0.04182, which is exactly what we got. Okay. So normally we just use this table so that we only have to use one table, essentially. Okay. Just to show it one more time in Excel, if we wanted to do this one in Excel, you would go to the so actually the normal distribution, there's the normal distribution function, but if you are trying to find The normal distribution will give you the less than. If you want the greater than, then you can use the normal inverse, which is this. Okay. Actually, I think that's something different. Maybe? Let's find out. No, that's something different. I'm sorry. That's definitely something different. Yeah, we're just gonna have to use the normal distribution then. And then so you're just gonna have to use the normal distribution and then do 1 minus that. So we'd put in x as, the advantage of this is we don't have to standardize it. So we put in x is 82. Our mean is 56. Our standard deviation is 15. And then we do want the cumulative function. So we get the 0.95, all that. Because we have a function, though, we can just come up here and do 1 minus that. And then it'll give us our 0.041518. Okay. Again, it's a little different than this, right? 0.4182 versus 0.04182 versus 0.041518. And that's just because of rounding. So you can do it in Excel. You can do it in, you can do it the same way in Google Sheets. You can do it using the table. I would just use the table. If you have a graphing calculator, you can also do it that way. That's the way that the book goes through doing it. It has the table way, but it also goes through the way to do it in a calculator. And I could also show you how to do that too. I don't have exactly the same calculators then, but I have a similar one. So yeah, I think that's going to be it for today though. So next time we'll do chapter 7. Like I said, that's a short chapter. So after we do that one, we're going to get into chapter 8, which is where the statistics really starts, right? Because here we're still doing a lot of probability. And same with chapter 7. So we'll do that one, which is confidence intervals, probably 2 lectures from now. And we'll do chapter 7, which is the central limit theorem, in the next chapter. Okay, so thanks for watching today. And yeah, I'll see you for the next one.